Hey everyone, and welcome to another event of the Monthly Dev. I'm already seeing a lot of familiar faces down here in the comments, so thank you all for coming. I'm super excited to host you all here, and let's get it started. So if this is your first time visiting and joining us in the monthly Dev, I want to tell you that we host it once a month. It's free for everyone, and it's always an online virtual event. We keep recording it, and it's always available for you on our YouTube channel. So if you haven't done it before, make sure to subscribe to our YouTube channel right now so you won't miss any new meetup or any new recording. Again, thank you all for coming. Let's have a look on who is going to talk today. We have an incredible lineup for you. So coming up first, we have Michael from Storybook. Then we have Justin from Google, who is going to talk about lit web components. And lastly, we have Shodipo from Stack Overflow. And just before we start and just before I introduce you to Michael from Storybook, make sure to open up your Twitter account, Instagram account, Facebook, or whatever social media that you love. Grab the YouTube link right now, paste it into the post, add the monthly dev hashtag, and then tell the world why they want to tune in and join this awesome event that we organized just for you. And we will pick the 10 most creative shares, and we will send you a laptop sleeve with daily.dev brand. Just one logistic thing, make sure to keep your DMs open so we can contact you in case you win. So do it now before we start. And without further ado, let's introduce and let's call up Michael from Storybook. Hey, Michael.
Hi, Ido. Thanks so much for having me.
Thank you for coming. How are you?
Very good. A little tired. It's late here.
And are you ready for your talk?
Ready as I'll ever be. Pretty excited to be here.
So let's get it going. So good luck, Michael. Let me put on your screen, and I'm there in the back scene.
Fantastic. Let's jump into it. I'm going to give y'all a quick introduction to component-driven development with Storybook. This is just kind of an overview of what Storybook is and what you can do with it. My name is Michael Shilman. I'm the project lead. I'm too lazy to change my GitHub and Twitter avatar, maybe yearning for a time pre-Storybook, before open source made all my hair fall out. I'm really excited to talk about components, first of all. I guess Justin is coming up next to talk about lit. That's the lit logo down here in the middle below. But we are living in the component era. UI components have really changed the way we build UIs. They are fast to build, fast to execute. They're modular, and they are reusable. It has never been so easy to build UIs, and UI components have never been so Lego-like. Even Rails and backend services are starting to use components. So nevertheless, front-end development is still really hard, despite having great technology to use. On the left, we have a perfect design, and on the right, we have a poorly executed product. And as developers, it's our job to get it right. So I'll talk a little bit about some of the challenges and how component-driven development helps solve them, and how Storybook helps enable that. That's the gist of the talk. So when we're building out a product, Typically, if we're working on a sizable product, we have a designer. Designers provide screens and staggering complexity. Products are easier to build than ever, but because they're easier to build, complexity is sort of table stakes. We can throw more screens at it. We can throw A/B tests at it. We can throw whatever, and we get these screens as input, and somehow we need a systematic way to convert all this stuff into structured components. That's what component development is. So first, I guess one thing that we could do given a screen is we could decompose that screen into all of its low-level components. And then we could look for common components and build them out. And then we could assemble lower-level components into higher-level components. Apologies for the blurred images here. And finally, given these higher-level components, we could assemble these things back into the screens, back to match the design. So this is like an idealized picture of a systematic way of building out a screen, keeping in mind that we may have tens or hundreds of screens and a bunch of different states for those screens. And that's the essence of component-driven development. So it's a top-down process, but the building of components is bottom-up. Start from low-level components, build them up cleanly, combine them, and finally build them into an app. Why is this hard? It's hard because your app may have flaky data, may be hard to reproduce a specific state in your app. Your app may have complex logic on the front end, on the back end. Testing all the logic is a lot of work. You may be building a front end and you may be building it against a back end, and the back end may not exist. So these are kind of three common challenges. Enter Storybook. Storybook is an open source tool, and it's a workshop for building UI components faster. I will take you through a quick tour of Storybook, and then we'll actually look at some storybooks. So the main purpose of Storybook is to catalog all the UI components in your application and all their states. We call these things stories in Storybook. Each story is kind of a clean room environment. So I mentioned this is a workshop. My father was a carpenter, and he had a workshop, and it was filled with sawdust and all sorts of mess. Storybook is kind of the opposite of that. It's really about a clean environment for building these things in isolation. Building a component in isolation enforces modularity, and it's great for stubbing out hard to read states. A story in Storybook is a simple JavaScript function. So this is a file from Storybook just for a simple button component. We have the title of the component, which is kind of where it shows up in the navigation hierarchy in Storybook. We have the component that we're writing stories for, and then we have a number of key states for that component. This is a button in normal state, linking state, and loading state. So now some things to know about it. It's compatible with every major view layer, React, Vue, Angular, Ember, Rails, Marco, Lit, Svelte, HTML5 web components, and probably a dozen other ones. Why this is good, it means that you can learn Storybook once and then reuse it as your UI stack evolves. It's easier for frameworks to integrate. So as new front-end framework come onto the scene, as they inevitably do, they will typically have Storybook support. And finally, Storybook is supercharged by hundreds of add-ons for documenting your components, for manipulating your components with controls, for interfacing with design tools, for kind of design developer handoff, testing, showing the source code, doing accessibility tests, theming your components, and on and on and on. This is the workshop aspect of it. It's filled with interesting tools. So at this point, I want to kind of dive in and look at a storybook together. I have a storybook from the BBC, and this is kind of give you a sense of like some of the stuff it can do. So BBC, this is the first time I've seen this storybook today, actually. Somebody turned me on to it, and here is a full page built out in Storybook. Again, on the left-hand side, we have navigation. On the top, we have some tools. We can look at it in like a mobile setting, in portrait mode. We can look at it as like a blurred vision simulator for accessibility. We can look at accessibility tests. So we see like one accessibility violation here, and on and on. There's 100 different add-ons. But it's interesting to look at the BBCs because we can see some stuff and kind of see what they care about. So at the page level, they have a full page. They show some error pages. They show error pages in right to left. They have like the front page in right to left. They have a radio page, and so on and so forth. So they even have like loading behavior. And they're really building out their entire app, web app in Storybook. The other thing that I have up here is I have kind of like the low-level components that feed into it. So they have another Storybook here. Here there's an old add-on now deprecated called Knobs, but it kind of allows you to manipulate this stuff so we can see kind of different branding. I don't know what these different knobs do. We can tweak the colors of stuff. We can we can play around with it. And the idea here is that there's a bunch of different brandings. I guess there's a lot of like internationalization. So this is something that they really care about because they're an international site. But the gist is that with Storybook, they can kind of map out all their states for both high-level pages, and then they've chosen to do this separately, low-level components. They have even little things like captions, a consent banner, which we saw on the main page. We have like how they show figures with a copyright overlay, and so on. These are kind of like very much working storybooks. You can tell that like this was somebody building out a site and saving all their work as they go. We'll get it more into why you might want to do that later in the talk. This one over here is a very polished storybook, more for public consumption. This is the World Food Program storybook, also something that I was just turned on to today. So this one has a lot more about kind of documentation, all written in Storybook. It has a kind of quite a bit of sort of introduction, even style guidelines. And then if you get down here, there are a bunch of different, atomic low-level components to be reused across a variety of sites. So that's kind of a little quick tour of Storybook. And Storybook is used pretty prominently across the industry. The tools that you use every day, many of them were built in Storybook. Twitter's web UI was built in Storybook. The Slack UI was built in Storybook. GitHub's UI was built in Storybook. Storybook recently added support for Rails view components that I alluded to earlier. This is a screenshot from the GitHub React components. If any of you have seen the new GitHub Projects feature that's in beta, this is clearly UI from that. It's pretty cool to find, and thousands of teams use Storybook to write millions of stories. Everything from developer-focused companies like GitHub and Atlassian and GitLab to consumer-focused like BBC, Audi, and so on. Anyway, this is just scratching the surface. Airbnb was one of the first big adopters of Storybook, and I believe that all of their web UIs are built out in Storybook, which should be great. I guess maybe you work on a big team and maybe you already use Storybook. Maybe you don't. Maybe you're working by yourself or in a small team. So what? How does Storybook help you become a better developer? I think there's two different answers to that. One is kind of, you just need to try it. This is a quote from Andrew Frankel from Salesforce. Storybook is crucial to our UX process. The old way seems ludicrous now. What does that mean? It means that probably Andrew and his team have gotten used to building out their stories in Storybook. It's just part of the flow. It helps with a variety of things. And as you kind of get into the Storybook ecosystem, you learn those things. But if I had to single out one area where Storybook really shines, it is testing. And so I want to give a quick sort of spotlight on testing. And once you go back, you never go. Once you start, you never go back. Exactly. Well, hopefully that's that's by choice and not by obligation. So like testing in UI is really hard. I won't go into all the details, but for a given component, you may have 4 key states. Those 4 key states might render across a bunch of different browsers and a bunch of different viewports and be tested for a bunch of different use cases or criteria, like simple testing, correctness, also accessibility testing. Multiply this by thousands of components and you've got your work cut out for you. And writing tests is typically hard. However, writing stories is really easy. And if you write stories for your components, sorry, I jumped the gun there. It's really easy for bugs to slip through based on the context that a component is rendered in. But one of the things that we've built out based on Storybook is visual regression testing. And the idea is that every time a story changes its appearance, we can detect that automatically and we can flag it. And so sometimes that change of appearance is intentional, and sometimes it's accidental. And this allows you to build out components with a lot more confidence. If you could see all the changes that happened in a particular commit or a particular pull request, you would be able to know exactly what changed. So this is kind of a workflow of detecting visual changes. This is using a service called Chromatic, which is built by the maintainers of Storybook, including myself. And this basically detects all the changes in a PR, allows you to go through and visually inspect those, and then turn your PR green once you've validated those changes. So it's super fast because all of the data that you need to render your stories is local in the Storybook. So it's all kind of mocked out. This is a real screenshot. So we're running over 2,000 tests in 45 seconds. And that's because of this kind of component-driven development process where we've mocked everything out in Storybook. And so here's kind of a screenshot of what that looks like. We inspect the differences. We accept the changes that are intentional. We can also deny changes. And then once those changes have been accepted, your PR turns green. So that was a quick introduction to Storybook. I don't know how much time I used. Maybe that was faster than I expected. But I hope you got some flavor of what Storybook is about, what component-driven development is about, Chromatic, a tool built on top of Storybook, how that can help you. And I've put a couple links here. We have a bunch of tutorials on the Storybook site. We have a blog where we share out release information. We have a Discord that's linked from there with a pretty friendly community. And if you would like to ask any questions, I'm happy to answer now. Thank you.
Thank you very much, Michael. Here is, we have one question from Nimrod. He's asking, what's the next step for Storybook? What's coming up next?
Oh, man. We have a bunch of stuff. I would say the main focus for a while has been on performance. So in the next release, we have rewritten the core of Storybook to make it like roughly 3 times faster to load, 4 times smaller bundle size. And so performance has been a thread that's like, especially as teams are building out storybooks with thousands of stories as teams use it more heavily. And so we'll be doing a lot more work there. Another major area that we are focused on is testing. So I sketched out one type of testing in the talk, which was a kind of visual regression, automatic snapshot testing. But we're building out a bunch of stuff for automatically interacting with components and asserting things about those components, more kind of traditional testing. And so we'll be shipping the first iteration of that in a few weeks, and have kind of a whole arc of testing planned. And then the last area, something that's been kind of going on for a while in the community, which is about building full pages in Storybook. So I showed some stories early in the talk, and those are like really simple stories of like a button with a label, and like it's kind of easy to conceptualize that. But when you actually build out full pages that are interactive, they're fetching data, they're doing all sorts of crazy stuff. I didn't show an example code of that because it wouldn't have been so easy to grasp. But the community's been building out a lot of interesting add-ons for supporting that, whether it's like mock service worker for mocking fetch requests, or Apollo GraphQL client, and so on. And so these are things that have been kind of like happening in an uncoordinated way. In Storybook Core, we're going to kind of build some things for centralizing and stylizing what it means to build pages in Storybook. And so turning Storybook from a kind of low-level component workshop into kind of building your whole app in Storybook.
Yeah, I think what you mentioned it as part of your subtext, but what people may have missed is that Storybook is actually a marketplace of many add-ons, and you can write your own add-ons and share them. So it's not just a standalone product, you know.
Yeah, and we have a handful of add-ons that we kind of provide, as we call them essentials, which are just kind of like guaranteed to work with the latest. But really, we rely on a pretty wide community. There's probably around 300, 400 add-ons now, and that's where like a lot of the research happens, right? Like this kind of page level stuff, like we can't figure out everything. So it's really cool that that folks are kind of pioneering that, and now we're trying to formalize that and kind of build it back into the core.
Yeah, definitely. And we have one more question. Can we integrate Storybook in our application, like render Storybook on a certain route?
No, you cannot. This is something that people have requested. It's something that we've considered quite a bit, and it's a potential roadmap feature. But at the moment, Storybook is kind of an isolated, standalone application, and there's a lot of reasons for that. Although we see the desire to render it as a route, and that may be coming as well, but not on the roadmap.
And another question is, there's some news about Storybook supporting Stencil.js.
Oh man, Stencil. Storybook for Stencil is the single highest upvoted issue in the Storybook repo. The Stencil team underwent some form of reorg / expansion recently, and I'm in touch with them, and we are looking to build an official Storybook for Stencil. There's some challenges there, but I think we'll probably figure that out later this year, early next year.
So I guess stay tuned on GitHub and subscribe to the issue is the best way to.
Yeah, and for sure when it's available, we'll be shouting about it since we know a bunch of people want it. But yeah, it's not a trivial integration because one of the things that Storybook kind of depends on is what Webpack. And so, like, why are we able to support all this stuff? Like, A, it's because we do a lot of work and the community does a lot of work. But like, B, for the last 5 years, Webpack has been kind of like
de facto
a fairly universal thing. And Stencil doesn't play with Webpack. Storybook is starting to play with other stuff like Vite and other types of builders, and so there's certainly room there. But yeah, we need to figure out with the Stencil folks the best way to kind of make those two things happen. Nothing concrete there.
And last question is, I think you talked a little bit about it before, but what are the plans for Storybook Composition in the near future?
Oh yeah, so Storybook Composition feature I didn't talk about, but basically it's a way of taking multiple storybooks and joining them into one storybook. We released it about a year ago, and it's gotten some traction. We are releasing an update in 6.4, which is coming out in the next few weeks, which will make composition a lot easier to set up. And that's there's a set of manual steps that you need to do to set it up historically, and now that'll all be kind of automated as part of Storybook built in, which is great. And then the other, moving forward, we will continue to invest in it. I would say probably the biggest thing is like the use case for composition is to develop storybooks for multiple frameworks. Typically, like I have a Vue version of my components, I have a React version of my components, I have a Lit version of my components. I want to show those all in one storybook. And so one thing that we'd love to do there is kind of monorepo support. So it's really easy if you have like a bunch of those packages in the same monorepo to just get a single composed storybook that rolls those up together. Again, not on the roadmap, but as we are kind of pushing forward on various stuff, I'm always looking for opportunities to invest in composition, and I'm hoping that 6.4 will give a good shot in the arm to that feature.
So the future is looking bright.
It's hopefully bright. It's always a wild ride and pretty crazy. Whenever I talk about all the stuff that we're doing, I start to get a little headache. But yeah, we'll be cranking out a bunch of good stuff for you.
So Michael, thank you very much for coming. It was such a pleasure, and by looking at all the comments, people are in love with Storybook, and those who aren't yet, they just very eager to try it out.
Wait for the next version, and it'll get incrementally better. Thank you so much, Ido. I really appreciate it.
Thank you. Bye-bye.
Cheers, everybody. Bye.
Before calling Justin on stage, we have a big announcement today. Just recently, we hired new members to our team, so please make some noise in the comments, show them your love. We have Lee and Chris, who joined us as software engineers, and we have Francesco, whom you might know from Tech Twitter, who is joined as a developer advocate. You will see them around. They will be part of our core team. They will help us build daily and make it bigger. So please show them your love on the comments. And while talking about it, it's also important to mention that we are also hiring data engineers. So if you know Kafka, you are good with clouds, you know how to move tons of data from one place to another, how to crunch it. We are looking for you. So we will send the job application link in the comments in a few moments, and make sure to apply, and we will reach you out. And for our next talk, please welcome on stage Justin from Google, who is going to talk about lit web components. Hey, Justin.
All right. Hey, Ido. Thanks for having me.
Thank you for coming.
Glad to be here. That was a nice talk from Michael. Yeah, so I'm going to talk about web components in lit. All right, we have the slides up there.
And good luck.
All right, thanks a lot. Okay, everyone. So my name is Justin Fagnani. I'm an engineer at Google working on web components and a web component library called Lit. My Twitter handle is Justin Fagnani there. And yeah, so today I'm going to talk about both web components and Lit and give you kind of an overview of where things are at today and just how the ecosystem and how things are doing in web components. But first, I'm going to get everybody up to speed. So in thinking about the audience out there, I didn't know what anybody kind of knew about web components. So we're going to start from zero a little bit and have, I'm not going to assume any prior knowledge of lit or web components. So we'll go over these real quick. So yeah, what are web components? Well, web components are the web's built-in UI component model. They allow you to create your own custom HTML elements. And they also have a lot of features that are familiar to kind of component models that were already out there, like scoped DOM and scoped CSS. But web components focus on interoperability. You can use web components anywhere you use HTML and in any framework, and I'll get into that a little bit too. But web components aren't exactly like a framework. They leave a lot up to user or developers to kind of fill in some blanks. And this is where Lit comes in. So Lit is a library that we make that helps you build web components. And specifically, it brings to the table reactivity, so declarative reactive properties, and declarative templates that we re-render for you when state changes. And that's all built on top of this core reactive lifecycle. It's the reactivity model for Lit elements. And so with the declarative templates and the reactivity model, we try to bring just what you need for web components, but we try to keep everything very, very lightweight and fast. And when I say that web components are the web's UI component model, I don't know if people have heard the phrase out there, if you want to know the best place to build roads, pave the cow paths. The cows have already found, the good paths to walk on. And this is kind of what web components do. Even though there's a lot of purported differences between frameworks, it turns out they have just a lot in common, maybe more in common than people think. And so web components try to kind of learn from that and standardize a bunch of the common bits. So these are things like component lifecycles, templating, composition, state. Actually, this list here is things that are common to frameworks, right? Encapsulation, reactivity. Most frameworks these days build these types of features in. And so web components basically tackle a few of these problems and build them into the HTML standard. So web components take on things like lifecycle. And it turns out that most framework lifecycles are very similar. They let you do work when the component is created and mounted and disconnected and updated. And so for the most core lifecycles, you can kind of create a one-to-one mapping between most frameworks like React, Angular, Vue, etc. Web components don't have templating, but we'll just skip ahead to composition. So you can build a web component out of other web components. And you can compose web components together when you use them. You can have children that you put into a web component. This is a very common feature across frameworks too. Web components help give you encapsulation of both the DOM that a component creates and the styling. And there's that styling there with CSS. Web components let you style in an encapsulated way. And then most frameworks these days use built-in DOM events, but some kind of cross-component communication is usually a piece of frameworks, and web components take care of that too. So of what I estimate to be the main component model features, web components kind of take care of a bunch of them. But they don't take care of everything. So web components don't look exactly like the frameworks you're probably used to, right? The way I think about this is that frameworks usually combine the component model with helpers for implementing that component model, including the templating, reactivity, and state. And so web components are just focused on this external interface of the component, how it interacts with the DOM and other JavaScript code, right? So they don't give you everything that frameworks usually do. That internal implementation is left up to the developer. So that's the things like templating and state and reactivity. And this is a great place for libraries to help out. So you don't need to use a library. You can write a web component with no dependencies at all right in your dev tools if you want. But Lit and other web component libraries like Stencil and Lightning Web Components and a whole bunch of others actually, these libraries help you implement web components. And one way to think about this is that we have these two categories of features, the external interface and the internal implementation. Your component users in the browser itself are going to interact with the external interface, and the component authors are going to build the internal implementation. So this separation is one of the things that makes web components unique. Usually a web component or a framework will bring both parts of this component model, and web components are bringing the outside, and Lit is bringing the inside here. And this is also kind of helps us think about what web components really are. They define a standard for this external interface and how that interface integrates with HTML, CSS, and the DOM. And the benefits of the web component specs defining this external interface are twofold. One, you can choose what libraries or no libraries at all that you want to use to implement the component. And two is interoperability. So components work together regardless of how they're implemented. And they work with existing systems that handle HTML. So the main one is the browser itself. But then we have other frameworks, content management systems like WordPress, Markdown files. Web components are HTML, and so they work with a lot of existing tools. So for example, the public external interface of a web component in HTML is just the tag, just like any other HTML tag, right? But the difference is you get to define your own tags. And these tags can have attributes. So we can put some Boolean attributes on here and a value. And they can have children. So this would be similar to other frameworks like React or Angular that can also have features that are very similar to this. But this is just standard HTML. There's really nothing that special here, except for that web components let you make your own HTML tags. And anything that can create HTML can now use your web components. But this here is just the HTML interface. HTML elements also have a JavaScript interface that's exposed by the DOM. All right, so you can get a JavaScript reference to an element. You can query select something out of the document, or you could create one with create element. And then you can do things like you can add event listeners, just like on built-in elements, or set properties. And these properties can be any type of value, by the way. They could be primitives like strings or numbers, or they could be complex objects and functions. And because it's just HTML, you don't have to interact with it imperatively, like on the previous slide. you can use it in your favorite declarative templating system or framework, like JSX here, right? So here we have that same carousel, and we're going to build the children out of data. And this all works just because it's HTML. Okay, so that's a glance at how you would use web components. So let's take a look at writing web components. And so first, I'm going to go through writing web components without any library at all. And web components are kind of composed of two main specs: custom elements and shadow DOM. And custom elements here let you define a new element. And the key thing here is that this class extends HTML element. So ES6 and some standards back in that era made it possible to extend built-in classes. And one of the ones that the browser added was being able to extend an HTML element. And so you can do things like create a constructor and do some initial setup of your component. And this would be very much like the render function, the component function in React, or a constructor in Angular or something. And then what you do is you tell the browser about your custom element. So there's a global called custom elements. You call it define, you give it a tag name and the class. And now when the browser sees that tag, it's going to create an instance of this class. So pretty straightforward there. But you're going to want to do more than just have a constructor, empty constructor run. You want to actually create some content in your web component. So that brings us to the other standard here, which is shadow DOM. So one thing web components, or all elements in the browser, or nearly all, there's some exception, are able to do is add a shadow root to your element. So we see this call here, attach shadow. And that's going to create this variable on your component here called shadow root. And what a shadow root is like a separate private tree just to contain your internal DOM for that component. And the nice thing about this is that internal DOM is kept encapsulated in private. Query selectors do not go into it. CSS does not go into it. And so we can create the shadow root here. And if you were to put an instance of this element on your page, you would see hello world. But you'll notice this doesn't have any children, because that H1 that displays the hello world is actually in the shadow root. It's not a child of the element. So this kind of encapsulation is one of the things that powers interop, right? That way a framework can put children in this component and not overwrite the content of the shadow root. A really important part of shadow DOM is composition, and that's enabled by what are called slots. So a slot is like a hole in the content of a component where the children can be put in. And if you're familiar with props.children in React, this is very similar to rendering the children here, except for that it works with any children that are DOM elements. They don't have to be from the same framework. So to see how this would work, let me go back here. So we have an H1 that says hello world, and we have a slot below it. So this says put any children here. And this can actually be a little more flexible. You can have name slots and put different sets of children in different places. So when you go to use the element, now you can put a child here. And you can see that up here, we're going to have that content below our H1. And you see we still have the H1 encapsulated. We've given some children here. We have not overwritten the contents of the shadow root, and we see both of them. So that gives you composition. And it's interoperable composition. You usually can't have, say, an Angular child of a React component. They don't know how to cooperate that way. But with web components, you could easily have a stencil child of a lit component, because each component is just a standard web component. And it's actually the browser, not the libraries, that are doing this composition here. Okay, and then finally, another great feature of shadow DOM is scope styles, like I've mentioned before. There's a number of ways to do it, but right here I just typed an inline style tag to show that you can write a pretty generic selector. Here we're going to have an H1 selector, which is going to select this element down here. And if you render that, you will see that your H1 up there is red. And the nice thing about this is that selector does not leak out of the element shadow root. So it doesn't style any other H1s anywhere else on the page or in any other shadow groups. So we get encapsulation, scoping, custom components, composition from these two standards here. All right, the nice thing about web components is they are supported in all current major browsers. Not just current, like all of these browsers have supported web components for a while now, going on 2 years, I think, for Edge once it switched to Chromium. And not only is it supported in all the current major browsers, it's also seeing a ton of growth in usage all across industry in the ecosystem. So this is a little snap of logos from a website called Are Web Components Ready Yet? There Yet? Something like that.com. And a lot of companies are adding their own logos to this to show that they use web components. There's actually quite a bit more than this. And so it's seeing a lot of good uptake. Not only companies building applications, but we see a ton of design systems built with web components. From companies you've heard of like Adobe and ING, to Ionic, who makes Stencil, to independent design systems like Shoelace. And so there's too many to list here, but design systems are a really great use case for web components because we see that people want to be able to use their design system in multiple frameworks without having to re-implement it for each framework they support. And the web components ecosystem is thriving and doing well too. I want to give a quick call out to a group called Open Web Components. This is a group of people from a number of companies on the previous slide who are contributing to kind of non-library specific recommendations and tooling to help people use and get the most out of web components. And we also have some efforts coming along that I'm really excited about that are going to help us collaborate more across these different companies using web components and making libraries. So we have a new W3c Community Group, just called the Web Components Community Group. And this group is helping kind of collaborate on common protocols for communicating between components, things that are not necessarily in the standards, but could be done via APIs and events, and creating reports for the browser vendors about what next steps are the highest priorities for web components. And so all this ecosystem and adoption by companies, it's really helped increase the usage of web components that we see out there. And so we see the stats for web components going up, and I'll be cheesy here, web components are going to the moon, almost literally. So like one of the coolest uses of web components we've had in the last year or so is that web components are probably the first framework in space. They were used to build the user interfaces for the Dragon capsule that SpaceX sent up sometime last year in 2020, I think. So this is a touchscreen interface running Chrome and web components. And they use that for all of the astronaut controllable features in the Dragon capsule, which I thought was extremely cool there. Okay, so it's not just a cheesy joke either. The stats for web components are looking really great. So this is custom element usage in Chrome, and they've been going up for a long time. And currently, we're looking at something like 17% of all page loads in Chrome are using custom elements. So those are huge numbers. I mean, there's not a lot of other web features that are created in the last 5 years that are being used on as many pages as custom elements here. And if we had to guess why that's possible, it's again this interop feature that web components have. That if you create web components, they're usable in all the main frameworks that people are using out there that you might want to support, and the smaller frameworks too, or something that hasn't been invented yet or no framework at all. So the superpower of web components is really driving a lot of usage across the industry. Okay, so that's a bit about web components there. Now let's jump into Lit. So Lit is the library I work on, and it helps you build components. Our tagline is that Lit makes it easy to build fast, lightweight web components. And to show why Lit is necessary, I want to go back to a vanilla web component without any library helpers. So the hello world thing I showed earlier was very, very simple, kind of glossed over keeping any state and doing updates. So here's an example that is a little more complicated. It's still a bit simplified, but it shows some of the things you need to consider when you're building a web component. So in the carousel element I had before, we had a couple attributes. In order to actually get notified when those attributes are set or changed, we have to declare them with this property here called observed attributes. This is part of the custom element spec. So we need to put a couple attributes there. In order to have a property that's settable that reflects to an attribute, we are going to need some getters and setters here. So this is the speed property. And this, when you set it, is going to set the attribute. And when you get it, it's going to get the value from the attribute. And you might also want to have something here in the setter that causes this component to re-render when you change the speed. I don't even have that part here. Then you have the constructor, which sets up the shadow root like I showed before. But you're also going to have to respond to changes in attributes. So we have this method here called attribute change callback. And these are pretty low level APIs here, right? Like a lot of these correspond to features that are in frameworks, but frameworks have tried to move up a level and make things a little more declarative and to get rid of boilerplate. And so this is possible with web components, but you need some helper libraries to fill in those features that the web components standards don't directly address, right? And this is what lit does. So we try to give you just what you need to make declarative reactive components. So we have a fast declarative templating system, reactive properties, the reactive update lifecycle, and we make it very easy to define styles with your component right in JS. So here's an example of a lit component. And it has some of the same pieces, but we've tried to make things a little more declarative and less boilerplate. So the first thing you'll see is that we have the component declaration here. So I'm showing a decorator example if you're using Babel or TypeScript, or hopefully an upcoming version of JavaScript that has standard decorators. We offer this decorator API to make things a little bit more declarative. We also have a standard non-decorator API that you can use. So here we have the element declaration, and it extends lit element instead of HTML element. And then lit element itself extends HTML element. So you're still doing the standard platform thing of extending HTML element. We make it very easy to add scope styles. So you add a static styles property here, and we're going to automatically attach this to the shadow root, and these are going to be scoped for you. And then we make it easy to define reactive properties. So instead of having to write your own getter and setter and have the setter do some work when things are updated, we have a decorator here that just writes a getter and setter for you, and that setter recalls the component to re-render. So that's how we get what you might think of as props in React or inputs in Angular to cause a component to be reactive. And then we have what's probably the core of most elements, which is the template. So lit uses what we call the lit HTML template system. It uses tag template literals, which are a standard feature of JavaScript, to do some special processing on this string. And we are able to pull the expressions values out and basically create this DOM for this component once, and then remember where these expressions went in the DOM and update them only when they change. So you get fast, minimal DOM updates here with no compiler and standard JavaScript syntax. We've augmented the HTML syntax just a little bit to be able to do declarative event handlers and declarative property setting into components. And then finally, down here, you might see that you reference an event handler on your method. So this isn't all the features of lit, but it kind of shows the most important ones and how we've tried to reduce boilerplate and make these things as declarative as possible. And then, of course, once you build a component with lit, you can use it just like you would use any other web component. You don't have to know that this component was built with lit or any library at all. It could have been built with no library. And so this is that abstraction power of web components, that there's a standard interface into them, no matter how you've built them. So this is repeating the previous bit again, but we have these lit features here that are our most important things we consider. So we have the declarative templating, the reactive properties, the style in JS, and that reactive lifecycle. And so this is what lit has been offering for its kind of like first two and a half years of life. But recently we had a big lit 2.0 launch. And lit 2.0 was actually the first version of what we would call lit right now. Previously, we had these like separate libraries called lit HTML and lit element. So lit we launched just earlier this month, last month. Kind of losing track of time in these days. But lit 2.0 is basically a version of lit that has unified the entire project. So we no longer really refer to lit HTML and lit element separately. We have a unified project, a mono repo they're under, a new NPM package that combines them, and a new website called lit.dev. It also has a number of new features besides those core features that I just mentioned on the previous slide. And it sets us up for a lot of exciting evolution in the future. So some of the new features we have, I'm going to gloss over this real quick because we don't really have time to get into this. We have a new declarative class-based directive API. So users or developers are able to extend Lit's template system using what we call directives, and we've made that easier to write and compatible with upcoming SSR features that we have. We have async directives that are able to do work before and after render, so you're able to do some pretty advanced things like animations. We have a new type of binding, so you can attach behaviors very easily to elements. And we have a thing I'm going to show in a second called reactive controllers, which you can think about a little bit like custom React hooks. They're a composable unit of reactivity that we think is going to be very useful for building out component sets and utilities. We also have added ref and static expressions and a few more security features. So Lit 2.0 is jam-packed with new features, but the nice thing about it, it is largely drop-in replacement for Lit 1, and Lit 1 and Lit 2 components just work side by side. So you don't even have to upgrade like your whole app. You could just start using Lit 2 in new components. This is again due to that power of interop with web components. All right, next, I want to point out something that I think is hopefully coming through here is that one of the things that Web Components offers is the ability for people to have differing opinions. So in that orange box I showed in the external and internal parts of a component, on the orange box, on the internal side, you can have different components, different teams, different developers that have different opinions about what the best way is to build a component. And those components can all still work together. And Lit's opinions, we think are good, but they're not the only ones. So we use standard JavaScript. Aside from the TypeScript decorators there, which are optional, we generally don't require any tools at all. So we use tag template literals instead of JSX. We basically rely on standard class inheritance, things like that. We don't have any compiler, yet we're still one of the fastest and smallest libraries out there. We are able to do this by using some of the caching work and HTML templates and a few features built into the platform that let us make the library very fast and small, even without a compiler there. We also embrace classes. And the reason for this is that we want a system that lets us have a declarative syntax for combining state and behavior. And classes already give us exactly that. And the way you write web components without a library is to extend HTML element. We didn't want to move too far from that and have like a completely different syntax for it. We wanted this to be familiar to people who might be, who know the standards. So instead of extending HTML element, you extend lit element. And that kind of goes along with the last point here is that we really want lit to be a thin layer. We don't want to hide the platform that's underneath. We want to just augment it and add what you need. But like I said, the nice thing about web components is that other opinions are perfectly fine. And components built with different opinions in mind or in their implementation still work together. So for instance, Stencil is another popular web components library. It takes a different approach. So it uses JSX and a compiler. And it doesn't actually directly expose the HTML element base class. You kind of write this like controller class. So it keeps you a little bit more focused, I guess, maybe from the DOM API. There's also a library out there that can use Lit called Haunted, which gives you React-style functional web components. So instead of a class, you write a function that returns a template value. And that has hook support. So that's another valid opinion. And that one doesn't use a compiler either, because it can use the tag template literals. Fast is a framework from Microsoft that's very similar to Lit. It uses no compiler and also embraces classes. LWC, Lightning Web Components, those are from Salesforce. I am not 100% sure if they use a compiler or not. But the cool thing is it doesn't matter, because if somebody built a component with LWC and I wanted to use it, I don't have to care how that component is actually built internally. And then finally, a lot of frameworks these days have the option to compile to web components. And so you can use their opinions as well. Svelte has like a light fork of JavaScript and HTML and a compiler to build components. and then an option to output web components. Vue has a compiler as well and a slight fork of HTML, and it's also able to produce web components. So web components really enable what I like to call like democratization of trying out different ideas of how we should implement components, yet making them all compatible at the same time. Okay, so that's a rough idea of what lit is. Let's see how lit's doing. So first of all, lit is probably used a lot more than you think. I try not to look at stats too much, but it's kind of hard not to look at something like NPM downloads. And lit has been growing a ton since we released it in like mid 2017, and especially in the last year. So right now it's approaching about 500,000 NPM downloads a week. So that's still small compared to the major frameworks like React and Vue and Angular. But for comparison, it's downloaded from NPM about half as much as Preact. And Preact is quite popular. And it's about twice as much as well-known frameworks like Svelte and Ember. So lit is doing quite well, at least by this one statistic here. And we also have a ton of partners and customers using lit. So this is a little collection that we show on our website, but there's a lot more than this. So a lot of big companies are strategically choosing lit to build out large portions of their websites and portfolios, including something that was very, very exciting that was announced today, which is that Adobe announced the new Photoshop for the web, which you can just go to in a URL in Chrome, and it is built with web components and lit. And hopefully my screencast is working here. We are extremely excited about this. We've been working with the Adobe web team for a long time, and the fact that they can bring web components, Photoshop to the web with web components is just awesome. So here it is actually running. I don't think this particular account has my Creative Cloud enabled, so I don't have like my editing layers over there. But you can see parts of the API over here. All this stuff is web components and lit. And we can verify that by opening up DevTools and going in and just inspecting some elements. Now, I might need to zoom in a little bit more. But we can see these components right here: SP split view, PSW, that's Photoshop Web panel container. These are all web components, and they are all built with lit. And we can see what versions of lit they're using because we add a little version tag. Okay, they're using a pre-release version of lit element still. They should kind of update that. And they're also using some older versions of lit in the same app. So they probably have a build system that builds multiple bundles. And the components all work together because it's web components, and it doesn't matter which exact version of lit you use inside the component. Also, lit element in total bundled and minified is probably about 6K. So this is not actually adding that much compared to the rest of the application out there. So it's something we're extremely excited about. Like, big congratulations to the Photoshop team and the Adobe Spectrum Web Components team. We just couldn't be happier about seeing this go public. Yeah, so that's exciting. You can build very, very complex applications with web components and lit. If you want to try it out yourself, you can just do an npm install of lit, and then you can import lit element in the HTML template tag from lit and get going. But the easiest way is probably to go visit our new website, lit.dev. So this is a unified website for all parts of lit, the component model and the template system. And one of the coolest things about our new website is that we have an interactive playground. So this is probably the easiest way to get started and try out lit. So you can go here. This is a screenshot. I think I'm just going to go to a live opening of the website here, and we'll go to the playground. Zoom in a bit. So here we have a multi-file playground, and we live load it into an iframe over here with the help of a service worker. So we're actually loading all of these files directly into the iframe over there. And we can go ahead and edit. I don't know how to say hello in some other language there. So you can edit, and you can see the live updates go on there. So you can try out lit right away. And we also have a switch here that lets you choose between the standard JavaScript syntax and the TypeScript syntax with decorators. And you can do this for all of our examples here. You can switch between JavaScript and TypeScript. So it's a very easy way to get going and to try out different features of Lit. And we have a tutorial and a bunch of different examples there. Okay, so that basically brings me to the end. This is a very kind of quick overview, but I hope you got a flavor or a taste of what Web Components and Lit have to offer and how the ecosystem is doing there. And I wanted to bring up this slide again, because I think this is a very important thing to remember with Web Components and components in general, is that the key thing that makes Web Components unique here really is that Web Components define this external interface into components. And that the internal implementation is up to you. So you can choose a library like Lit or no library at all. Last thought is that Web Components really offer a few values, and we try to adhere to those in Lit, that are important, and especially for big teams, right? So one is interoperability, right? Components can work with no framework or any framework at all, and legacy systems like content management systems. So this is very important. The other is evolvability, right? So you can change how you build components. And you can do that in a backwards compatible way. If you go change how one component is built, it doesn't necessarily break any of the use sites of that component. The other is stability. So Web Components are going to be around now basically as long as the web. And because of the interoperability and evolvability, there's less lock-in to any specific Web Component library. So our customers definitely feel like Web Components and Lit are very safe bets because of this. And finally, we have flexibility. So if you wanted to build your own templating or reactivity library, or you wanted to try out one that you thought was interesting made by somebody else, but maybe that library doesn't have a realistic chance of getting huge adoption like Angular or React, Web Components give you the ability to try it out anyway. To experiment with new ideas or use other people's experiments in a real app. And this, I think, is a huge gain for the web in terms of not getting stuck at like a local maxima and being able to try out smaller libraries. There's a lot of good stuff out there on the web, and we want to enable all of it to work together. All right, so that brings me to the end. Thanks a lot for hanging in there. Again, my name is Justin Fagnani, and I'll leave you with a couple of links that are useful for web components. There's the lit.dev website we have, openwc.org, and because web components are a standard part of the web platform, you can even read docs there on MDN. All right, thanks a lot.
Thank you very much, Justin. This was incredible. Actually, we've got a lot of questions here. I hope you've got some time.
I'm good. Yeah, let's go.
So let's get it started. First question is what's the advantage of using web components over React?
So I hope I kind of touched on that on the last slide there. Mm-hmm. The main advantage that's most obvious is interop. Now, interop, matters when you need to interop with different things. Like if you have a specific framework that you've chosen and you know that every single component that you use and write is going to be in that framework, then you don't really need interop. But I would argue that every application eventually is going to either die or need interop. Right? Either it becomes unmaintained or it needs to start using components from somewhere else or upgrade to a different framework or something like that. So interop is the main key. And then I think that the other advantage is, kind of an ecosystem advantage too, about being able to have low lock-in and experiment with different ideas, but still be compatible with the rest of your app.
Another question that you might have answered during your talk is what is a good approach to manage the inputs inside the Shadow DOM?
Right. So this question is referring to the fact that Shadow DOM encapsulation can be a bit too strict sometimes. So what's happening with inputs and other form elements is that they don't by default associate with a form that's outside of that shadow. They are encapsulated. So there is a standard for this called the form data event or form associated custom elements, but that standard is not implemented in all browsers yet. And so you might have to use a polyfill, or another approach is to slot your inputs in and use them as children so that they're in the same shadow root as the form. So yeah, this is evolving right here.
Why styles property is static?
Good question. Mainly because for most components, styles do not change per instance. Like what we recommend doing with styles that need to be dynamic is using CSS custom variables and changing their values. So by making it static, we have a bit of a performance win. In the most modern browsers like Chrome, we're able to create what's called a constructible style sheet, which doesn't even create a DOM element, and just reuse that style sheet in every shadow group. So that works as long as the style sheet is just exactly the same. So that's why it's static.
So it's better like to toggle between styles using classes and normal way of toggling styles rather than dynamic styling.
Yeah. Instead of creating new style text, we recommend toggling classes or attributes or using the style attribute to set some custom properties or something like that.
Another question, what about performance and semantics in web components or in Lit?
Yeah, so Lit is very fast. Lit has a whole system where it only changes the DOM it needs to, but it's also faster than most VDOM systems because instead of calculating the entire VDOM tree every render, Lit just remembers exactly where the expressions go to in the DOM. It actually replaces those expressions with comments so that it can, have a little marker for exactly what DOM needs to be updated. And it does all that work ahead of time. It does it just once per template, no matter how many components you have or how many times you render. So when you render, all it needs to do is update the DOM where that marker is. So it's very, very fast. If you look at benchmarks out there like JS Framework Benchmark, Lit is definitely on the faster side of things, more so than most of the mainstream frameworks, I'd say. In terms of semantics, the semantics of web components are just HTML elements, and that's another thing that I really love about them.
So I guess they are compatible with all the accessibility stuff and accessibility attributes and whatever, right?
Yes, so you can put your accessibility attributes, you can put them in Shadow DOM, on the components that need them. There is, along with the form association spec that is being implemented now, there's also an ARIA extension that lets components basically kind of like programmatically like tell the browser different ARIA attributes for components, and so that's trying to make it easier to forward ARIA stuff. So if somebody put an ARIA attribute on your component, you could kind of tunnel it into the elements inside of your component that need it.
Is there a difference between web components and custom elements?
Yes and no. So web components is kind of an umbrella term that refers to mainly the custom elements and Shadow DOM specs together. You could also consider the HTML template spec as part of web components, but it's not strictly necessary. And it used to include HTML imports, which was something that isn't used anymore.
How to test such abstractions, basically how to test web components.
Yeah, so I mentioned the OpenWC project. They have actually branched out into two. One is called OpenWC and one is called Modern Web. And they have a few libraries called like the Web Dev Server and the Web Test Runner. And basically these enable you to, create your components right in an HTML page, however you want from JavaScript or HTML, and then start interacting with them from JavaScript. And to run your test scenarios and your assertions and everything. We don't have any particular library you have to use. You don't have to use Jest. You don't have to use a real browser. You can. We generally recommend using something like Web Test Runner with real browsers, using Puppeteer or Playwright. And we usually, on my team, use Mocha and Chai to set up our test scenarios and run them. So we run unit tests, but directly in the browser. And that way we know they work in all browsers. We run them on Safari and Edge and even IE.
You can also use Storybook for visual regression and stuff, linking to the previous talk.
Yes, that looked awesome, and I know they have some good lit support too. So I have not tried out their visual regression testing yet, but I really want to.
Another question, can you import external CSS in the Shadow DOM?
Yes, so you can load CSS in a number of different ways. One thing that was just added to Chrome and hopefully coming to other browsers soon is the ability to import CSS into JavaScript modules. So you just import mystyles.css right up with the rest of your JavaScript imports. And that'll give you a CSS style sheet object that you can actually give to lit in the static styles property. So that's like the most modern and easiest way to do it. But then you can also load styles with fetch. If you're using a bundler, you can have the bundler give you the CSS text for you. There's a number of different ways, and then you can put that style text into your Shadow DOM with a style tag.
That makes sense. Last question. What about SSR? And then I will add, what about, browsers that don't, not browser, but situations where JavaScript is not supported?
Okay. Those are very interesting questions. And we have some things going on there that I did not talk about in the presentation here. So one of the things we've done with the Lit 2.0 launch is created a new area for stuff to develop from our team called Lit Labs. And one of the main packages we have in Lit Labs right now is Lit SSR. And so this is a system that lets you load your Lit components into Node. It shims just a little teeny bit of the DOM. Like it creates the custom element registry and the lit element or the HTML element base class, but it doesn't really emulate a whole DOM. And we're able to call the render methods of your components and get those results back out and incrementally stream them along with the values back out to a web server there. So we have SSR implemented. It's in Lit Labs right now because it just isn't tested enough, and there's like a few missing features or edge cases that we still have to get to. So that's probably our main method of doing SSR that we're investing in the open source world. It turns out in Google though, Google doesn't run Node at all, and Google's main frameworks do SSR on Java servers, and so we have been working to make like a restricted subset of TypeScript and Lit that can actually be compiled to Java. Yeah, it's a awesome system that's like pretty wild. Didn't necessarily think you could do it, but yeah, it's not open source though. But it goes through. Google has this closure compiler system that we use, and we basically can generate closure templates, which can then generate Java and Python and C++ and stuff like that. So I don't know how much of that or when we would be able to bring that work externally. But I definitely know there's a lot of enterprise users who are on like C# and PHP and Java who would love to be able to do SSR as well.
So if I understand correctly, the technique for doing the SSR is kind of HTML over the wire kind of stuff, like
yes, so
send the snippets of HTML.
Yeah, so the way it works is there's also a new standard called Declarative Shadow DOM. And this actually lets you put shadow roots right into your markup, and then when the browser gets that, it can recreate that shadow root, put the styles from the style tags in there, and basically get your component rendering before any JavaScript loads. So yeah, the technique is to basically evaluate your component tree, and then as it's being evaluated, stream out parts of the templates of the components inside of these declarative shadow roots so that when the browser gets them, it can start painting right away.
Wow, that's interesting.
Yeah.
Okay, this was all the questions. So thank you very much Justin, for coming.
All right, thanks for having me. It's great being here.
You bet. Enjoy the rest of your day. Thank you very much.
Okay,
Bye-bye.
Thanks. Bye.
Unfortunately, Shodipo from Stack Overflow couldn't make it in the last minute. He had some emergency stuff going on, so we are deeply sorry he couldn't attend. But so with that said, we are super happy that you all came and joined this event. We had fantastic 2 talks, and if you missed some of the event, it's all recorded. Make sure to subscribe now to our YouTube channel, and you will get all the updates. Another important thing to mention is that starting from the next event of the monthly dev, we are changing the hours to make it more accessible for everyone. We got some feedback that it might be too late in some countries, so we make it a little bit early, like 1 or 2 hours earlier. So make sure to check the new hours on our meetup page, and see you soon next month. And until then, enjoy the rest of your time. Bye-bye.